In the last class, we discussed what a queue is. We have seen that initially the size of the queue is 0, yes, and then we saw as and when we push elements into the queue, like I said, as and when we push elements into the queue, we expand the queue, we expand the memory of the queue. So who is doing this memory management? Memory management is being done by the simulator itself. Here we are not managing memory. In case of dynamic array, what are we doing? We are managing memory. But in case of queue, the memory management is into the simulator. All we need to know is how to use the queue. How to use the queue is to by pushing the elements either to the front or to the back. And then we also discussed what are the common mistakes what people do while popping the elements out of the queue. If you use for loop to pop the elements out of the queue, what happens? What problem you encounter? What is the problem that you encounter when you pop the elements from the queue using a for loop? Only you will get only half or nearly around half of the elements. Why? Because why is that? It is because your size keeps reducing, and as and when your I index becomes greater than the size of the queue, you break the for loop. And to for that mistake, the solution is don't use for loop. Or one thing, if you still want to use for loop, make size as this, the initial size. Take a variable, store the initial size, and loop through the for loop with the initial size of the queue, not the current size of the queue. I repeat, the solution to that problem is don't create a for loop by every time checking the current size of the queue, but instead have a for loop which runs for the initial size of the queue. See what I'm doing? I'm first taking the size of the queue into a local variable and storing. Here I will get a 10, and then I will loop through in the for loop. Here the value is the same, right? Now next time, even if I'm popping, the data size is changing, but I have the initial size with me. I have the initial size with me. Because I have the initial size with me, I can retrieve all of the data. I'm not checking for the current size of the queue. I'm just starting and looping around the for loop with the initial size of the queue. So this is the solution to that problem. Then we also discussed what is the best way to pop the elements out of the queue. The best way to pop the elements out of the queue is using while loop. Why is using while loop the best? Because you don't risk it. As long as there are elements in the queue, you keep popping them. So using while loop is the best way to pop the elements out of the queue. So this is what we have discussed so far. Now today we will discuss what a bounded queue is. So in this example, as you can see, I have just put colon. Now if I just put this, it becomes an unbounded queue. Now along with this dollar sign, I have put 5. What does this mean? This means a bounded queue. What is a bounded and unbounded queue? Unbounded queue is the queue whose size, at least in theory, is infinite. It is not bounded at all. But a bounded queue is the one whose size is fixed. Here, as in case of array, if in an array I gave 8 here, what is the size of this array? Fixed size array. If I place an 8 in front of it, can you tell me what is the size of this data? The size is 8, right? If I put 8 there, the size is 8. If I say data is equals to 8 byte Rajat, because each location is 1 byte wide. So there are 8 such locations. So it is 8 byte. Now, if I say equal to new of 8, again it becomes 8. So what is the size of this then? If I'm giving 5, what is the size of q? Will the size of the q become 5? No, initially for bounded, unbounded, the size is always 0. Keep that in mind. We are not giving size, we are not fixing the memory. We are just fixing the maximum memory that the queue can take. Please make a note of it, guys. Here, by using a bounded queue, we are not fixing, I repeat, Here, by using the bounded queue, we are not fixing or we are not allocating the size of a queue, but instead we are limiting the maximum size of the queue. To start with, the size of the queue is still 0. When will the size of the queue increase? The size of the queue increases when you push elements into it. When you push elements into it. But by this, what are we doing? We are limiting the maximum index. So see, bounded queue with a number of as the rightmost index. Now tell me, guys, we have also seen what is front and what is back of the queue. Which index is the front of the queue? Which index is the frontmost index of the queue? Zeroth index is the frontmost element index of the queue. Great. Which is the index which is the lastmost element of the queue? Front is 0. Back or last is size minus 1, isn't it? Size minus 1. Whatever data dot size, if data dot size returns you 10, then the if data dot size returns you 10, then 9 is your backmost element, isn't that? In the same way, what is 9? 9 is a maximum index. In the same way, when you write 5 here, so what are you doing? You are limiting the maximum write index. Maximum index on when it increases, when you say push back, the elements that happens to enter into the new index and the maximum index it can grow to is 5. That means 0 to 5. What is the total size of the queue then? If I say 5 is the maximum index to what the queue can grow, then what is the size of the queue? The maximum size number of elements that it can store are 6. Because 0 to 5, it is not the size. Here you see 8 means the size. Then the total indexes are from 0 to 7. So whatever you give, minus 1 is the index, but here you are giving index itself. So index plus 1 is always the size. See, index 7 plus 1 is the size of an array, which is 8. Here index is 5. 5 plus 1, 6. The total size of the queue with 5 used is 6. Remember this. Here, for fixed size arrays, for dynamic arrays, we are giving the size of an array. But for queue, we cannot give the size because memory management is not in our hands. It is onto the simulator. So you say the memory can increase or decrease for this queue, but the maximum index which the queue can take is 5. If the maximum index of the queue is 5, that means its size is 6 because 0 to 5 are 6 elements including 0. So the size of the queue becomes 6. Now what happens when I push elements beyond 5? What happens when I push elements beyond 5? Overflow, not underflow, Santosh. Overflow. You have a bucket, it is full of water. You try to pour in more water, what happens? The water overflows from the bucket and spills over, right? In the same way, if in the queue you have only 6 locations, you're trying to push the 7th data, 8th data, what will happen? It will overflow and the data is lost. So that is the common problem. That is what we are going to see today. So calm down. Just a sec. Is Pratik and Shlok in yet? Raksha, what kind of party did you take them to, man? Hmm? Party too hard? They're not up yet. Just a sec. Let me try calling.
Muted.
Pratik, Pratik, class join कर लो please. Yeah, yeah. Yeah. Oh, oh.
Unmuted.
Okay, they will be joining in a minute. Now we are discussing. Now what will happen if I try? If in the same example you see we are in mistake, we have also discussed what the best way is, and we have to come down. We have to come down and see what an overflow and underflow scenario is. So for that one, what we will do is first we are pushing 10 elements into data queue. Come and see what is the declaration of data queue. The declaration of the data queue is this. That is, we are limiting the size to 6. That means the 4 elements will overflow over here. Fine. And then let's see when we are popping the elements from the queue. We are popping the elements from the queue. Now data queue. Okay, let me uncomment this. This is how I'm popping the elements. Now if I try to pop more, it will give me a fatal error. So I am going to restrict myself by using the best way to pop the elements from the queue, not create an over underflow. If I create an underflow scenario, I'll get a fatal error and the example will not move forward. So I'm only popping the elements that are present in the queue. I'm not going to pop more. Okay, then we will deallocate the queue. So these are the two ways in which you can deallocate the memory or flush the queue, just by delete. Either pop it or use delete, or you can also use this construct to refresh the memory or flush the memory of the queue. Come down. Uske baad what are we doing is, here I am doing a few things. I am going to swap two numbers. Okay, now if I inside 437. Okay, this is to answer someone's doubt. Forget that. Display the frontmost. We have seen data of 0 is the frontmost, and these are the two ways. Yesterday we have, or day before yesterday, we have also seen how to print the lastmost element, how to peek the lastmost element or the back element without having to pop them out, is by using data dot size minus 1, or you can also use this construct. This dollar sign will give the size of the cube. This can be only used in the cube. Okay, so how do you pop the lastmost or the back data? Is by using data dot size minus 1. It will give you the last index, or use dollar minus 1. It will also give the last index. Okay, and now how to append data? Just like, see, we were doing the last most index plus 1. See, if let's say for example, see, today's is mainly theory and understanding the queues further, that's it. So index 0 is nothing but the front. We have labeled this, isn't it? Now the last one, dollar sign, is nothing, dollar sign minus 1, isn't that? Minus 1 is nothing but the back. Now if I say push back, I have one more element. I say push back, it comes here, isn't that? If I say push front, it comes here. Although it increases from here, but it comes here. So again this guy will become 0, this guy will become 2, so on till up again until dollar minus 1. This is how it goes, isn't it? Now if I use this, If I use this, that means I want to push the element at the back. Don't you think this concatenation operator is going to do that? So if in other ways, if you want to restrict yourself and not use pushback, but you want to add elements to the queue at the back or at the end, you can use this construct. That is concatenation construct to push the elements to the back of the queue. In the same way, to push element to the front of the queue, you have to have this. You have to have this. So this will push element to the front of the queue and this will push the elements to the back of the queue. See, currently what are we doing? Data dot delete. So the data is fresh for us. Data dot delete. What it is? Okay, let me keep that commented so that there is no underflow over here. What are we doing? I'll go back again in this example. What to expect? The size of data and the size of data queue 0. Then we are trying to push test 10 elements to data and data queue, and we are also displaying what we are pushing. But here what happens? Data is an unbounded queue, but whereas data underscore queue is a bounded queue, isn't it? See, data is an unbounded queue. Data underscore queue is a bounded queue with a rightmost index bound of 5. That makes it a size of 6. Then what are we doing? We are popping all the elements from the bounded queue. Then what are we doing? We are just displaying the elements. We are not popping, displaying the elements of data. Then come down to the elements of the data which are already present. We are using this construct to justify that this is another way of pushing the elements to the back as well as at the front of the queue. Okay, as well as to the back or the front of the queue. Now to create an underflow situation. To create an underflow situation, what happens? I have to pop more data. So why don't I also comment this and pop it in that way? It's one place. So comment this, save this, come back to the example. So to create an underflow, we'll pop 10 location. Data underscore queue does not have 10 location. It has only 6 locations. So this will create as an underflow. Now we also need to know how to insert a data between or at an index that I want. So in this data queue itself, sorry, we will choose data. In data we are having 10 locations. So from those 10 locations, what we'll do, we'll insert. Using insert, we can insert the data in the middle, that is at the third index. What happens to the data which was at the third index already? It gets pushed to 4. Now see, I said right, the only way to access there, what are the two ways to access queues that we have seen so far? Is either using push pop methods, that is only accessing the push and pop methods, that is only accessing the front and the back. We have also seen that we can loop around using indexes and also read or peek the data either front or back using 0 or data dot size minus 1, or you can loop around in a for loop and print all the elements of the queue. We have also seen that without popping, if you are using for loop and printing all the elements of the queue, we have also seen it. If we can do that, that means we can replace or override any of the values. Fine, we can do that. But can I insert an element in between the queue? Let's say I want to slice this queue open like this and insert one element in between over here. Can I do that? Yes, I can do that, because like I said, it is for verification. For verification, we might need to have all these conditions where I want to corrupt few locations from the queue. I want to add few more locations based upon priority in middle of the queue. I want to pop location from the middle of the queue. That is where this insert and delete operator comes in picture. See, what am I doing here? I want to insert on the third location a value of ff. That is what I'm doing. At the third location, I'm inserting a value of ff. Then after inserting, I'm printing that. After inserting, I'm printing. See, after inserting, I'm printing all the locations just to see that this got pushed into. This is before printing. This is before inserting the data. This is after inserting the data, so that we will know at what location it pushed this. What was the earlier value at the location 3 and what is the new value and what happened to the previous value which was present at third location. Then we can also use delete. Sorry, this should become delete. We should also use delete. What does delete do? Delete will remove the data which is present at that location. Delete will remove the data which is present at that location. So again we are printing the entire queue after delete. This is the example. These are the array manipulation methods. Basically this is everything you need to know. But before running this example, I would like to ask you any doubts, any concerns. I know that I've gone through this really fast just to show that this is of really no importance. Whenever there is a need, you can easily come to the syntaxes and see. It's just that I want you guys to understand the concept. That's it. Concept and syntaxes of the queues and in what places they can be used. That's it. Nothing more on it. All you need to know about the queues, I've explained that in detail and slow. That is using while loops, using for loop, what the mistakes are, what is bounded and unbounded. All this insert, delete, this is not some things that you will come across every day or this things. Hmm? And also one more thing that I'm going to explain is if queues or dynamic arrays are used as a function call. See, if I have a function foo whose input is q. Can you give dynamic array as input? In an argument. Now again one more thing as a part of assignment. Can you do this? This I want any at any cost, okay? So as an assignment, create an example for a function using dynamic array as argument. Okay, so I will explain with q. See, I'm in this function foo, I'm using q as my argument. So how do I call this? How do I call this? So what are the different ways in which I can use it? Do you guys remember back in the day when we discussed what is pass by reference and what is pass by value? We have also seen functions with default values, isn't it? We have also seen functions with default values. What are those? Can anyone tell me what is a function with a default value? What is the advantage of using a function in an arguments with a default value? Don't remember? Okay, it is here. See, let's say I have function void add int a int b. Then the way to use this add is to pass add of 2 comma 3. Can I just say add of 2? Can I just say add of 2? What will it show me? What kind of error it will give me? Is it a compilation error or a runtime error? I repeat, is it a compile time error or a runtime error? No, here see there is no default value. That is what. Here there is no default value. Here you are supposed to pass both the values. But whereas in this one, I am giving A and B as a default values. Both have default values. So if I am passing these two new values, A will get a 2 and B will get a 3. But if I am not passing the second argument, only 2 will be given to A. Then I want to give value to B only. That means in this way I can do this. So only B will dot B. Here the order, see just like you instantiate your module in another module. There are two ways to pass the connections. First is order, the order in which it is. Second one is using dot name of the input or output. In the same way, it is same language, right? In the same way for function also, you can use dot and the variable name because it is out of order. Here you see in this one I want to give a value of 2 to only A alone. I don't want to give a value to B. I want to use b with its initial value, I will use it this way. Or here I want to change the value of b alone, I will say dot b. Or I don't want to give the values to both a and b, I will use add like this, I will use add like this. So this is function arguments with default values. So what is this? This is function argument with default values. So what are the advantages of having default values in function arguments? The advantage is that you are not supposed to pass the value every single time. You are getting an advantage that if you want to change the value, pass it. If you don't change the value, don't pass it. That's it. So in the same way, when queues are used as a function call, see here I'm using a queue inside an argument of a function. That means I'm expecting input q. Can comma is useful here? Which comma you are telling? Comma where, Saddam? So you just want to give comma here and then give the value of b. No, no, no. That means you are giving null value to a, right? First argument it says and the value is 0. That means nothing is passed. So it will give null to a. Cannot do that. If you don't want to pass a value, you cannot just leave blank there and go on. It will give you a compilation error. That will give you a compilation error. You have to pass a value. Now, here, when coming back to this, when I am using q as an input, how to make a q a default value? This is what it is. Now, when you give this, what will happen is q with only a size of 1. That means this 0 will be put at at a location first, that is at 0 index. Or if you want to have a q with more than 1, that means 3 in total elements in it, or 4 or whatever. So this is how you use. Yes, it is perfectly fine to use q as an input of a function, or even as an output of a function, or even as a return type of a function as well. You can also use q as a return type of a function. More on it next week when we cover type def. There is one full class that I have dedicated for usage of type def. That is, you use type def enum. Can you type def? Can you mix and match dynamic arrays and queues? We have already seen what a packed and unpacked array is, and we have also already seen how do we create a multi-dimensional array using packed and unpacked. Yes, now what we will do is we will create a multi-dimensional array using queues and dynamic array. So in that case, how is type def helpful? What is forward class referencing using type def? All of this we will discuss next week. But for now, understand that Q can be used as an input or output of a function as well as a return type of a function. When Q is used, I still want to go ahead and use a default value to a function, you can still do that by initializing the queue. So this is what is called as initializing the queue. This is what is called as initializing the queue. And you're not restricted to only using this constructive function here. You can also initialize a queue here like this. Here, if you want to initialize the queue, you can always go ahead and initialize the queue by placing an equal to and the construct, that is the concatenation operator that I have used. What it will do is it will push 0 at index 0, 1 at index 1, and 2 at index 2. So this is front and this is back. Think about that while writing this. Okay. Any doubts, any concerns, guys, while I simulate this example? Come on, what happened to this guy? Ruchita, Subha, guys there? Any doubts? Okay, Subha is here, nice. Ruchita join in. No. So any doubts, any concerns, sir? Sir, those are not there. Okay. No doubts. Is everything clear? Come. What is this? 107. 107. Unterminated. Where is that I started? Strange. Compile again and see. Unterminated block command. 107. So it started here. Oops. Oh, it started here, never ended anywhere. So just come back, compile, simulate this. So now, if you have no doubts, then I have one question for you guys. We have discussed what a drawback of queue is, that is, it can overflow or underflow. How you will solve that problem? First, let's say underflow. What is an underflow? There are no elements in the queue, you are trying to pop it out. If I am trying to pop out the elements from the queue and the queue does not have any elements in them, oh man, my server license checkout is not happening. Oh man, it's becoming slow every day. Okay. So tell me how you will use it. How you will make sure that queue never underflows. You have now know how to use a queue. You already know what the drawbacks are, so you ought to be careful. Now, in that careful nature that you want to develop, tell me how will you solve the problem when you encounter that the queue is empty and you're not supposed to pop more elements from it to create an underflow situation. Any solution to that? The solution is very simple and very straightforward. Unbounded queue, unbounded. See, overflow is only happening in case of a bounded queue, but underflow can happen in both the cases, right? Unbounded, I repeat, unbounded queue and bounded queue, they both will have underflow. Overflow can only happen in case of bounded queue. See here, this is first problem that we want to see. What is that? Underflow. So cannot pop from an empty queue. Why is that coming? Let us see. First, go ahead with the size of the queue 0, size of the bounded queue 0. Then the data locations 0, 1, 2, 3, 5, and these are the size of the queue. Data you put in one location, the size becomes this, that location is the frontmost location, that is the 0 location. 1 and so on. These are the 6 elements that we have put inside the queue. This is our bounded queue, isn't it? So these are the 6 elements that we have put inside the queue. After putting these 6 elements, 7th, 8th, 9th, 10th. So all these 4 extra location, what is happening? What is this called as overflow? I repeat, overflow can only happen in case of a bounded queue. Overflow can only happen in case of a bounded queue. Why overflow can happen in a case of bounded queue? Because we are restricting the maximum most index to 5. See here, we are restricting the max most index of a queue to 5. Come back to the example, compare and see here if that is the exact case. In the example here, what are we doing? We in a bounded queue, we are restricting the maximum index as 5. Come back here and see that the maximum index is 5. That means 6 locations I have posed in. Now the size becomes a 6. So first initially the size is 0. Then I am trying to push 10 elements. But unfortunately data queue has only 6 positions. So the 4 more will overflow. Overflow is a problem because overflow is not a problem. Because in case of an overflow, it is a warning. Now tell me, is overflow really a problem or not? What according to you is overflow? Is overflow a problem or no problem? Tell me. Yes, it is not giving fatal, all of that is fine. But unless and until you come to the log file and see that there is an overflow happening, how do you understand that there is an, like in case you are seeing, see this ALU, you guys are trying to verify, you are giving the status saying some are passing, some are failing. You, unless and until you go ahead, go into the test case and see how many are failing, how many are passing, you don't know. Isn't that? See, that is what our human nature is, especially we Indians. Careless, don't care what is happening. Test case pass or fail does not matter. Test is working, only that matters. To what extent it is working, again that doesn't matter. Keen eye for detail verification, transaction by transaction, I have to verify. Hey man, who's going to take that trouble? At the end, I want to see only one single line of print. Test case pass or fail. It passes. Did it create the scenario? Did it run? How many transactions were there? Who cares? Right? In the same way, in the same careless nature, what will happen is overflow, you will miss these warnings. Unless and until, see now, you have some 100 transactions. But literally in a much bigger protocol, you will have thousands of transactions going through, and for what transaction and what time, and the log itself will be in GBs. Literally it will be 5 GB, 6 GB log. You can even find it hard opening using Vim. You have to cut the log into 2 GB pieces and open it using Vim or edit, because you do not have the RAM to open a file which is of 5 GB or 6 GB in length. Yeah, so that is where, now if that is the line, literally it has lakhs of lines. In that one you will try to find these warnings to understand if the queue overflow. No. So there is, now if the randomization failed, how do you come to know? Let me put it this way. Let's say you're trying to, if object dot randomize. If the randomization failed, what happens? How do you know? How to know if the randomization passed or failed? Object dot randomize or randomize of a comma b comma c comma d. It returns 0 if fails. Exactly. That means I can in my code itself manage the fail and pass scenario and decide what to do. If randomization failed, if casting failed, I have if else loop. That means in the code, if it passes, I'm okay with it. If it fails, either I can throw an error or do something else to fix that problem, or do something else to fix that problem. But whereas in case of a queue, when it overflows like this, there is no return type here. In the code itself, I have no control. I will not know if it will overflow or not. I will not know. Let's say these 10 datas are very important for me. I want all the 10 of them to be gone to the other side. But unfortunately, because of the overflow, there is loss of 4 data. And in the code, I do not know that. and in the code I do not know that. Another problem, come back down, come back down. Then what am I doing in this one? What am I doing in this one? I'm printing all the locations of this one. I'm printing all the locations of data. Then what am I doing? Come back here. I'm printing all the locations of the data. See, I'm printing all of them. Hmm? Let's print. So starting with 0. Hmm? E3, all of this. Then E3 is my 0. That means this is my front. Start with data location 0. E3 is my frontmost element. The lastmost element is 5B. And these are the message where we are printing the lastmost element of the queue as well, right? So now for this data queue, front is 0, this is. So front data of the queue without removing or popping of 0 index. Lastmost element. See, did it print me the last element 5D or did it print me DA? Did it print me last or last minus 1? It printed last minus 1. Why did it print last minus 1 when we know that data.size would return me the lastmost index of the queue? Did data.size return me the last index minus 1 should give you the last index of the queue, isn't it? At least this is what the expectation is. Then why is it going minus 1 one more time and giving me the last but second data? So come back here and see what is happening. See, you are using dollar. Dollar means size minus 1, the last location itself. Fix it in this way. Fix it in this way. To use data dot size returns the size. Size is 6. 6 minus 1 will give you the last index. But whereas dollar in itself means the last index. It will give you the result directly as 5. Or if there are 10 elements, it will already give you a number 9 of that queue. That is why you use one more minus 1 extra, you ended up here. So this is the difference between data dot size minus 1 and using dollar. So avoid using dollar. Avoid using dollar. Why I say so? Because most of the people are not aware. See, you are not here to write a code which is not known to people. I don't know why people take proud in writing the logic or using the constructs which people are not aware of. That is not something to be proud of about, but that is really something to be scared about. Yes, it is my job to teach you everything. I am teaching, but I am telling you, don't use this, because you are not alone working in that project. Your code will be used by someone else as well. It should be very simple and very descriptive. Always write simple and descriptive code, because if someone wants to use it, he can use it with ease. If someone wants to modify it, don't be competitive here. I don't want someone else to modify the logic which I write. Don't become that person. Always be graceful, always be helpful. Say that whatever logic I write, you're okay to use it. Everyone should use your logic. Everyone should be able to do small tweaks and reuse your logic. Make sure that your logics are reusable at all times. So if you are doing that, if there are bugs, if there are issues in your logic, you get to fix it from multiple fronts, because multiple guys are using it, multiple ways those guys are using it. There have been multiple modifications to your initial logic. If it still works, not works, so you get to practice more. That is a practice for you. The more you share your code, it is the more you get to practice on it. So try to write simple and the code which is understandable to others. So avoid using this. Then what are we doing to the same queue? In the front we are in the back we are adding 90, and also in the front we are adding 90. So let us come back and see. Did we do that? Did we do that? I'm not printing. Okay, after that I'm directly printing underflow. In underflow, I'm trying to pop 10 locations from my data queue. I'm trying to pop 10 locations from my data queue. To pop 10 locations from my data queue, I need to have 10 locations. But how many locations I have there as max? Max index of 5. That means only 6. We have already seen that the 4 more locations that I wanted to push got overflown. They are not there, but I am trying to pop 10 locations, so it is giving me this fatal. So don't worry. What we will do is we can either use continue to continue the simulation, Okay, uh, break this, come back here, comment this underflow. Come, where is that underflow? Comment this underflow situation, recompile and rerun, and we will see how to insert and delete from the array real quick. Let me come back, compile. Raksha, Rajat, Harsh, Santosh, Nasir, Sobha. I cannot possibly take all the 13 to 14 names, but Manjunath, I don't know if Manjunath and Tausif or Kiran are there. Any doubts, any concerns, guys? Come on. So this is everything you need to know about dynamic arrays and queues. So one assignment that I asked you guys, that is two assignment actually, that is copy a data from a dynamic array to a queue or copy a data from queue to dynamic array, and I said very important, and no one has completed that assignment and given me. That shows the seriousness. Now again I've rerun. The problem of overflow is fixed. Front data, back data. After that, I'm also printing before inserting the data. See, after inserting this front of the data 90 we have, and at the back of the data also I've put 90, as you can see using this construct. Where is that go? This is here. Using this construct I have put the data to the front as well as to the back, and after this we are inserting what is at location 3. There is data 81 at location 3, isn't it? Then what are we doing? We are inserting ff at location 3. So let us see what is the display after inserting. Okay, 3 became ff, but what happened to the original data? It got pushed down. So there is no overwrite. You will create a new location, but you will not overwrite the previous one. Then after that, what are we doing? We are deleting the third location, so everything is back to how it was again earlier. This is how you use an insert to create a location in between, how you use delete to delete the location in between, how to peek the front and back without popping it. I have shown you how to understand which is the front and which is the back of the queue. I have made you understand the queue can be used as a function arguments. Yes. Queues can be initialized. Yes. Queues can be deleted or flushed. Yes. All of this we have discussed about queues and how to declare a dynamic array, expand it, shrink it, randomize it. That also we have seen. Any doubts, any concerns here, guys? Any doubts, any concerns? Anyone? How to overcome underflow? Think about it, na? See, the thing is right in front of you. All the lines are, it's just that, as a hint, multiple lines needs to be put together. Here, the problem to overflow underflow is the best way that I thought it. See here, you are only popping as long as there is data in it. Why you want to pop with a fixed size like this? Where did I fixed size like this? Pop it using while loop. Your underflow problem will be solved. Only pop as long as you have a data. How to avoid overflow? You really can't do that because there is no operator which, or no function call dot size returns you the size, but there is no function which tells you that if it is a bounded queue or an unbounded queue. Because see, underflow can happen in both bounded and unbounded and can be avoided using while loop, or you use if dot size greater than 0, only then use pop, or wait for dot size greater than 0 and then pop the element. Okay, this will solve the problem of underflow. To solve the problem of overflow, you need to know if it is a bounded queue or an unbounded queue. And there is really no operator which can tell you, or no function, no inbuilt support that can tell you if it is a bounded queue or an unbounded. Okay. Now, we have talked about this overflow and underflow problems, but most often where they occur and what is the solution from System Verilog to avoid it, we will see next. That is the introduction to Mailbox. What is Mailbox? Mailbox is also a queue, but it has two advantages. First advantage is that it has got a semaphore inbuilt, and second advantage is that it has a task. Instead of push and pop as functions, it uses a task called as get and put. What? Because there are tasks, there is a time. And what is that time? It waits for the time the memory is being allocated to it, and it also waits for the time memory is deallocated from it. So quickly, in the next 15 minutes, we will see what mailboxes are. So let me quickly again save ourselves some time. Let's pick a coded example already. Give me a minute. Mm. So we were discussing Q0, right? Mailbox, right? With us. Okay. Mailbox example. As I said, there are two advantages of using a mailbox. What are those two advantages? First advantage is that it has got an inbuilt semaphore. Good. And the second advantage is that instead of using a function, it uses a task put and get. If they are tasks, they will wait. What is that wait time? What is the advantage of using a task or a function? We will see. But before going there, the first point, concentrate. I said it has got a semaphore inbuilt. So now what is a semaphore? What is a semaphore? To understand what a semaphore is, I have this simple example. I need not write this example in front of you to really make you guys understand what it is. It is very simple. First, I have a bounded queue whose rightmost index is 4. What is the size of this queue? Pratik, what is the size of this queue? I repeat, what is the size of this queue? At line number 4, what is the size of the queue? Pratik, Shlok. First of all, everyone is wrong who said 5. Shlok is horribly wrong. He said 4. Why did you guys say 5? Because the maximum size, I repeat, the maximum size the queue can take is rightmost index plus 1. Which Shlok forgot? Okay, Shlok now he will remember. The maximum size of the queue is always the bound index plus 1. This shows the index. Now, what is the size here? You said 5. It is horribly wrong. Why is that so? Because here the size is 0. We are just limiting the maximum size of a queue. This was a trick question. Always understand that at declaration the size of the queue is 0. But because it is bounded, you should mention that The size is 0 because it is bounded. The maximum size that it can grow to is only 5. The maximum size to which it can grow to or expand to is 5. Then what are we doing? We have a transmitter who is running in forever. We have seen this. You guys have coded drivers and monitors. Everything will run in forever. Transmitter running in forever. Forever at a frequency of #1, he is pushing the data to it. Receiver with #2 receiving the data. So the receiver is slow, the transmitter is fast. And there are only 4 elements in the queue. And there are only 4 elements in the queue. Why don't I comment this? Simple example. Then receiver is slow. Then what are we doing? We want to create a manager to manage the communication between these two, to manage the keys between these two. So if I do not have that, let us first see what happens and then we will code this guy. Okay, now because there are forever, this example will never end. Let us run it for only 50. And what is join any? What is join any? Join any will wait for any one of the join any will wait for any one of the thread or fork to finish and then come out. Here how many we have? Here we have 3 forks. First one is the transmitter one, which is pushing the data or transmitting the data every 1 nanosecond. Then we have receiver, which is popping or removing the data from the queue and using it every 2 nanoseconds. So it is half the speed of transmitter. Then what we have, just wait for 50. So after 50 nanosecond we will come out and we will disable the fork, or else this transmitter and receiver will keep running and we will manually call $finish. So save this, come back here, let us see this. It's a very simple example how to use semaphore to solve this, and then we will see how to use a semaphore to solve this, and then later on we will see how mailbox usage will solve this. I can see how mail usage of mailbox will solve this problem without using semaphore, because mailbox comes with a semaphore inbuilt. Okay, now what is happening? Our queue is filled with warnings. What is the maximum size of this queue? 5. So 1, 2, 3, 4, 5. So there are 5 elements. And after that, when it was trying to push the 6th element, you got a warning, right? Saying that it overflowed. It overflowed. So you received 5 elements, and after that, this started popping up where the transmitter is fast and it is overflowing. This one, see, would exceed max rand index of 4, time iteration, blah blah blah. So all these warnings, why? Because the queue is overflowing. This shows that the queue is overflowing. The queue started to overflow. Okay, now what to do? How to solve this problem? See, to solve this problem, you have to either create an unbounded queue. First, there is, as a assignment again, can you guys give me the formula for calculating the size of the FIFO? There is a formula to calculate the size of the FIFO. Why to calculate the size of the FIFO? Let's say there are 2 clock domains. One clock is faster or slower than the other. Then how do you synchronize data between them? How do you communicate between them? Is by using FIFO. Those are the applications of FIFO, right? Between 2 clock domains, if you want to synchronize the data and make sure that there is no loss of data, you will use FIFO. Fine. Go ahead, use FIFO, no problem. But based upon what you will decide, because in here in simulation you can create a queue of infinite depth which is non-synthesizable, but in the hardware you need a size of a queue. You need the size of the FIFO. How do you calculate? Just think about it, browse about it, and come back to me. Now, how will I solve this problem? I will not solve this problem today. Let's do that tomorrow. But today, for next 5 minutes, I would like to have your attention and say what resource management is. This is resource, nothing but memory, nothing but memory. Now on a chip, it will be connected on a NOC or NOC, means network on chip or fabric, whatever you want to call it, okay, or interconnect, IC. If you see this term, you should know IC means interconnect, NOC means network on chip, or fabric means the same. Why all these names? Because it will be a common bus connecting multiple masters and slaves. So there can be another master or slave here, there can be another master or slave here, and somewhere you will have a core, and that is nothing but the CPU core, right? Central processing unit, the core. It will want to either write the data to it or read data from it. Then you guys from your college days would already know what a DMA is. Although do not understand what the working of it is, that is fine. But there is a DMA. Now DMA is also a master, CPU is also a master. Now let's say at one time, if they both want to access this resource, what will happen? There are locations, let's say 0 to 10 for this sake. DMA wants to write data to this 10 locations. CPU also wants to write data to this 10 locations. What happened? Think about it in the hardware. Yeah, race conditions is, yes, fine. There is one model name. So in the Verilog language or the simulator, you will see a race condition, fine. But in a hardware, what happens? In an actual silicon, data corruption will happen. Why? This guy would write a value of whatever to location 1. He knows that he has written a value, but this guy will also come and write the new value to that location. What will happen? Data get corrupted because it is his data now, not his data. The data got overridden. So data corruption will happen. Now we need to avoid it. How you will avoid it? By putting a vault. How you will avoid it is by putting a vault here. Now, if I have put a vault, that means this door, this vault will have a key, isn't it? Not very good at drawing, but let me try to draw a key. Oh, not bad. Yes, we will allow only. So what we will do, we'll create a vault and we will create one key. Now that means there is a door here. Now both of them will come at the same time, fine. But who can write in it? Who can write in it depends upon what key it is. Now if CPU wants to write it, what the CPU will do is he will take the key, he will go ahead, open the door and write all the 10 locations. Now it is his data. It is his data. So he will lock it, come back with the same key and be there. As long as he is using these 10 locations, those 10 locations are locked. DMA is not allowed to do. Now DMA, if he wants to use that location, he will wait till CPU is done with it. He has written 10 bytes of data to these 10 locations. Now later on he wants to read them back. Yes, it is his data. Again he will come, he has the key. He will open it, go ahead, read it. Now his job is done. He wants to allocate the memory. What he will do, he will give this key to the DMA. Now DMA has the key. Now DMA can go open it, use all those 10 locations, lock it and keep it with himself as long as he wants. I repeat, as long as he wants. So this will solve the problem of memory corruption or multiple guys accessing the same resource. The same thing we will do here. What we will do? We will create a vault with a single key, which is nothing but a semaphore. And then you take the key, you push the data and you drop the key. You take the key, you push the data, you drop the key. Now in this again will the problem be solved? No. This has got nothing to do with overflowing. That is why we created a manager. What this guy does? it waits till the size becomes 5. The moment size becomes 5, it knows that the queue is going to overflow. So it will quickly grab the key and hold it till what time at least 4 locations are fetched out from the queue, and then drop it back. So that the problem of, I have went through this example real fast, don't worry, we will discuss this tomorrow. The only thing that I want to get about semaphore from today is that there is a vault, and if there is a no vault, if there is no vault, multiple resources are trying to access a single memory or a single resource. There will be a conflict, there will be a data corruption. To avoid that, you create a vault around it and have keys. Now, tell me one thing. Can you have multiple keys? Can you have multiple keys? Here I gave you an example of one key. You need to also think about it. Can you have multiple keys? Yes, I can have. You can absolutely have multiple keys. How many resources in that one you can decide how many resources can access it at the same time, and who are not allowed, who has priority, who has no priority. All of these interesting cases along with mailboxes we will see tomorrow. So by then I have given you 3 assignments. One is copy data from queue to dynamic array. Second one is copy data from dynamic array to queue. Third one is, even I forgot what the third one is. What is the third one? With FIFO, I asked you to do something. What is that I asked you to do? Create an example for a function using dynamic array as an argument. And explain me how you will use dynamic array as an argument to the function. Okay? Any doubts? This is what I had for today, guys. Any doubts, any concerns, I'm here to address.